system will also go, the program will also go there from there when the computer will be turned off. Okay, again when you will turn on your computer, at that time from the ROM, the bootstrap will be loaded in the RAM, and the operating system will also be loaded there. Okay, then only your computer will be started. So therefore the time is required. Okay, so you know that turning on TV require less time to than turning on a computer. So the thing happens that the operating system is loaded there in the RAM, and that will take some time. Okay, and for that computer take time to start. Now secondary storage. So not only the operating system, the other programs also, other programs that are previously required programs which are allowed there, that programs will be stored, will be loaded there in the RAM, and then only your computer will start. Then the secondary storage, that is different to this main memory, which is non-volatile in nature, and it will store the data permanently. Okay, so hard disk is a kind of secondary storage that can store data in different tracks, sectors, or etc. Okay, so this disk surface is actually logically divided into tracks, and they are subdivided into sectors. So from track you have the sectors. Okay, the disk controller determines that the logical interaction between the device and the computer. So disk controller actually determines that which particular portion of the disk will be accessed by the computer. Okay, that is the logical interaction between the device and the computer. Now we have the solid state drives. We know that SSD, which is becoming very popular in every computer system. We are not going to purchase hard disk over there because they are less faster than the SSDs. Okay, hard disk are the less faster than the SSDs, and SSDs are the much more faster than the hard disk, and they are also non-volatile. Okay, so these technologies are becoming popular there because of their speed and performance. Okay, now in the storage system we have the hierarchy of speed, cost, and volatility. So you see that volatility. So you see that the speed of SSD is faster than the hard disk. Okay, but the thing is that the volatility matter is there. See that RAM is also faster. RAM is faster than the hard disk. Okay, but the thing happens that the RAM cannot store a data permanently, whereas SSD and hard disk can store data permanently. Okay, so there is the difference between the speed, cost also, because the cost of RAM is higher than the hard disk. Okay, whereas the cost of hard disk is actually less costlier than the RAM. Okay, so this thing happens that the storage system, for every storage system there may have some lags also. Okay, like the either it will be volatile or non-volatile, either it will be costly or non-costly or cheap, you can say, or the speed of the storage devices also can be differ. Okay, now we have two different terms. One is the caching and the other one is the device driver. Okay, so device driver, I have also already told that they are the device controller actually. So I'm telling for the caching first. Caching is that copying information into faster storage system. Main memory can be viewed as a cache for secondary storage. So for the secondary storage, like your hard disk, if you store something there, then that will be a slower storage system. But if you can copy something from the secondary storage to the main memory, then that will be done fast. Okay, so that is called the caching. Okay, caching means copying some data from secondary storage to main memory. Okay, means slower device to the faster device. Then device driver. So device driver is for each device controller, it can manage the IO. Okay, so for the printer you require device driver. For the suppose microphone. Okay, as I'm talking in microphone, so this microphone is actually required device controller there. Okay, for the mouse it required device controller. Keyboard requires device controller. So device controller means they are actually controlling or managing the IO operations. Okay, and they provides uniform interface between the controller and the kernel. So this device driver is providing uniform interface between the controller and the kernel. Okay, we can see the storage device hierarchy. So from the very first, if we have the magnetic tapes, they are slower. Then the optical disk is there, like your CD, DVD, etc. Hard disk is there, solid state disk is there, main memory, cache, and then your registers. So registers are much more faster than the cache. Cache are in the second order. Then main memory is there, then solid state disk is there, then hard disk, then optical disk, and then the magnetic tapes. Okay, so the speed hierarchy is actually decreasing from top to bottom, but the cost of the magnetic tapes are cheaper, then the optical disc, then the hard disk, then solid text disk, solid state disk, and then main memory, then cache, and then registers. So cache are much more costlier than RAM, your main memory, then the solid state disk, then the hard disk, then optical disk, and then the magnetic tapes. Okay, so that is actually the per bit cost, we can say. Per bit cost for the main memory is actually higher than the per bit cost of this solid state disk. Then the per bit cost of solid state disk is actually greater than the per bit cost of hard disk. Okay, also the cost actually getting higher because of the speed here. Okay, speed is much more than the speed of the SSD is much more than the speed of the hard disk. Therefore, the cost is actually differing here. Okay, so this caching, from this caching we will discuss in the next day. So if you have any question, we can discuss, or if you don't have any question, then we can stop this class. Next day we will discuss other things. Why do you need vectors in case of interrupts in operating system, and why do you need vectors? Okay, this question you came from that. Why do you need vectors in case of operating system? See that interrupts are actually some instructions that are coming to the operating from the operating system side, that whether you have to perform operation, whether the current instruction is to be executed or some other instruction is to be instructed, I mean to be executed. So
Sir,
yes,
sir, mic is not working.
yes.
So your mic is not working, so that's why a problem
Can you
has
hear me?
occurred.
Can you hear me?
Now it's audible. Yes, sir, now it's clear.
Yes, actually I told you that the interrupt occurs, that interrupt requires actually that suppose the operating, I mean the CPU actually is running some instructions. Okay, so one by one instructions are there and the data is actually there, so it is running the instructions. Now this may happen that in some particular portion the interrupt is required. Interrupt is in the sense that suppose some input is to be taken from the user, or suppose some output is to be shown to the user. Okay, at that time the CPU has to wait. Okay, the CPU has to stay idle because the CPU actually processing device, it is not involved in any input or output activity, so it has to stop its operation there. So at that time the interrupt is actually required there. So this interrupt will be will stop the function of the particular device like your CPU. Now there are different types of interrupt. I told you there are different types of interrupt, like from the trap, and then RST like restart interrupt, and then INTR interrupt request. These are there, and when the interrupt will happen or the interrupt will be done, then acknowledgement will be passed, means from the microprocessor or from the CPU to the particular device who is requesting for the interrupt. Then they will get an interrupt acknowledgement there, that is called the INTA, interrupt acknowledgement. So this interrupt acknowledgement will come that it is telling that the device, the CPU has interrupted, and you can perform your own task, or you can take the program control to somewhere else. So that is done, that whole thing is done by the operating system, and that is managed by the operating system. So operating system can handle the interact that is done for the different devices, like your CPU, the processing device, okay, for different functions to be performed, like input, output, etc., when you require to be interrupted, okay, when your device is required to be interrupted, that thing.
Okay, sir.
So next day we will start from slide number 21, and I will give you this node up to 20. Okay, from 21 we will study. Okay, and where I will give in the group or somewhere else. I'm giving to one of you. Okay, I'm giving to, what is your name? You are present here. So I'm giving to Sayanton. Okay, and Sayanton will share with your other friends. Okay.
Okay, sir.
So the question come in NetGate that I will tell later. Right now I am only discussing about the
Okay,
concept.
sir.
The question come in NetGate, that is different thing that I will discuss later. Okay. Okay.